Okay, now let's play some more games with the parametric equations. I'm going to type the parentheses, and I'm going to put t, and remember, before I go any further, I'm making t go from 0 to 1. You'll see that as soon as I finish the parentheses. And then I'm going to hit t squared. And I'm going to close the parentheses, and you see that my range right below those parentheses, let's see, I can't zoom in on that, but right below the t squared you see 0 less than or equal to t less than or equal to 1. And that is what you see here. In my range I'm going from 0 to 1. And t is, as t goes from that, t squared jumps up and it goes from 0 to 1, but of course you've got the parabola. Now I'm going to change it and to go to 3, and now you can see that the parabola has lengthened, and it is now the end, the very top of the parabola is at 3, 9. But I only have half the parabola, again, because I'm going from 0 to 3. Let's get the other half by going from minus 3 to 3. And now we've got that. What's interesting, let's go ahead and cross that out now. And let's make our next foray into parametric equations. We're going to go t, and I'm going to square both of them. And you may be thinking, what? Well, by the way, do you see when I do that, I get what looks like the beginnings of the square root. Basically, t is climbing at a rate of the t squared, and the y, or x is climbing at the rate of t squared, and y is climbing at the rate of t. So we have a variance because of those rates, and we get that squared term. We can, of course, go out to 5, and you can see that we just basically have the square root function right there. The inverse of the squared function. But I really didn't want to do that. I wanted instead, let's see, I was at 1. But I want to go instead to t squared in the y-coordinate as well. And something very interesting happens. I get this straight line. And you think, well, how is that? We have squared on both of them. But you see, t squared in the x-coordinate and t squared in the y-coordinate are rising, or they're increasing at the same rate. So essentially we have x equal to y. And that is exactly what we have with this line. This is the line y equals x. If I go from 0 to 5, all I do is make my line longer, and I make it longer by quite a bit. Oops, I went 51. We just want to go 5. That's going to take me up to 25 and 25. Why? Because t is being squared. 5 is, my endpoint is 5 squared, which is 25. So that's what's happening there. Now, finally, let's do something very interesting. We're now going to have, I'm going to type in the sine of 3t, comma, then I'm going to do the cosine of t. And again, t is only going from 0 to 1, and you're thinking, well, this is kind of weird. Let's slowly increase. Let's go now from 0 to 2. Oh. 0 to 3. 0 to 4. 0 to 5. 0 to 6. It looks like a spring, and it's just about to close. The reason it's not closed yet is I haven't gone all the way around to 2 pi. So I'm going to do that now. I'm going to write 2 pi, and there it is. It completes. What I think is interesting about this is that it looks like I have 3 lobes. that 3 is based on the sign of, or that number that's in front of t. Remember how putting the number in front of t decreased the period dividing by 2 pi? So now our period here is 2 pi over 3. For the sine function anyway. Now I'm going to watch what happens when I change the 3 to a 4. I get 4 lobes. When I change to a 5, I get 5 lobes. When I change to a 10, oh, by the way, obviously when I do with just 1 in front of the t, I get the unit circle. When I do 10, I get 10 lobes. You can count them, but that's what's happening there. So now here's something else that's interesting. Let's switch things around, and I'm going to do the sine of t in the x-coordinate and the cosine of 3t in the y-coordinate. Sine of t, comma, cosine 3t. That's going from 0 to 1. Let's go all the way to 2 pi. And you see now everything has just flipped from a vertical orientation to a horizontal orientation just by flipping the x and the y, which actually, when you think about it, that's what you'd expect. These are the kinds of fun things that you can see with Desmos and parametric equations. I hope you explore this and have a lot of fun.